Ever feel like your laptop is working harder than you are? Like it's putting in overtime just to keep up with you?
Hey, I know that feeling all too well.
Turns out, the way our computers process information using electrons might be a bit, uh, dot inefficient.
Yeah, that's a good way to put it.
And that's what we're diving into today, a potential future for computing that uses something called magnons instead of those pesky electrons.
Sounds kind of sci-fi, doesn't it?
Right. Magnons. Like something out of Star Trek.
Well, it might sound futuristic, but they're a real phenomenon.
Okay, so what exactly is a magnon?
Think of it like this. You've got a still pond, right? Then you toss a pebble in, and those ripples spread out, right?
I gotcha.
Magnons are kind of like that, except they're ripples of magnetic energy. They can carry information, just like electrons, but with way less energy loss.
So like, my phone wouldn't get hot anymore, even when I'm streaming.
Exactly. Imagine data centers that don't need those massive cooling systems, or smartphones that stay cool even when you're gaming for hours.
That's insane. But how do we even build a computer that runs on these, Magnon things?
So it all comes down to spin. It's a fascinating property of electrons.
Spin, like a spinning top.
Sort of. Electrons have this intrinsic angular momentum, like they're tiny spinning tops. And this spin, it creates a tiny magnetic field. When these spins align in a certain way, they form a wave that travels through magnetic materials. And that wave, that's your magnon.
So instead of electrons zipping through wires, it's these waves, these magnons, carrying the information.
You got it. And because magnons don't bump into atoms as much as electrons in a wire, they don't generate as much heat.
So less resistance means less heat, less wasted energy. That's pretty amazing.
It is. It's a whole new way of thinking about computing.
Okay, so we have these magnons, these super efficient energy waves. How do we go from that to, like, an actual computer?
Well, a team at the University of Vienna, led by Dr. Andrei Chumak, has actually built a prototype Magnon processor.
Whoa, hold on. A prototype. So this isn't just theoretical anymore.
Not at all. This prototype can already filter and route signals, like a super efficient traffic controller, but for data.
That's incredible. But how do we design, like, complex circuits using these magnons?
That's the challenge. It's mind-bogglingly complex, even for the top experts in the field.
Can you give us an idea of just how complex it is?
Imagine a puzzle with billions of pieces, all constantly moving. That's what designing a Magnon circuit by hand is like.
That sounds like a nightmare.
It kind of is. That's where AI comes in.
AI, like artificial intelligence.
Yep. AI is proving to be a game changer. By using sophisticated algorithms, AI can analyze a massive number of potential configurations and find the best ones.
So AI is basically helping us unlock a technology that we barely even understand ourselves.
Yeah, it's pretty amazing. Dr. Chumak's team actually used AI to design key components of their prototype.
Wow, AI designing something that humans can't even grasp. Makes you think, doesn't it?
It does. It's a powerful example of how AI can accelerate scientific discovery.
This deep dive is already blowing my mind, and we're just getting started. Okay, so we've got these Magnon circuits, potentially designed by AI. Where do we go from here? What does all this mean, practically speaking?
Well, the potential applications are huge, really huge.
Like what? Give us some examples.
Think about it, smartphones that can run crazy, complex AI programs without dying immediately.
Oh, man, that would be amazing. My battery is always dying.
Right, and think about data centers. They could run way more efficiently. We could have a huge positive impact on sustainability.
That's awesome. But I gotta ask, are there any downsides? Like, is this all too good to be true?
Well, there are always challenges with any new technology. One of the big ones right now is size. These Magnon circuits, they're still pretty big compared to the silicon chips we use today.
So we need to shrink them down.
Exactly. Researchers think if we can get these circuits down to, like, the nanoscale,
Nanoscale, how small is that?
less than 100 nanometers.
100 nanometers, I can't even picture that. For reference, how big is that, like, compared to a human hair?
Oh, a human hair is about 80,000 nanometers wide. So yeah, we're talking incredibly tiny.
Wow. So it's gonna be tough to make them that small.
Definitely. It'll take some serious breakthroughs in materials science and manufacturing. Scientists are looking at new materials with better magnetic properties, and they're experimenting with cutting-edge fabrication methods to try and crack this.
So it sounds like we're not going to see Magnon computers on store shelves anytime soon, right?
Yeah, that's probably true. But the progress is really exciting. The fact that we have working prototypes, even at this larger scale, shows how fast this field is moving.
It's like we're watching the birth of a whole new era of technology. Kind of mind-blowing.
Absolutely. It really is a paradigm shift in how we think about computing, and it all comes back to this incredible tiny thing, the Magnon.
I love these deep dives that make you realize just how much potential there is out there in the world of science.
It really is amazing. Every day we're learning more, pushing the boundaries, discovering new things.
Speaking of learning, maybe it's time for a quick recap of what we've covered so far, before we dive even deeper.
Yeah, good idea. Let's break it down a bit.
All right, so big picture. We started by talking about how our good old electron-powered computers have some, shall we say, limitations. They get hot, they waste energy, not exactly the most sustainable way to go.
Right, and that's where Magnons swoop in to save the day, or at least that's the hope.
These amazing little quasi-particles, these waves of magnetic energy, they offer a super exciting path towards faster, cooler, and more efficient computing.
Way more efficient, and the fact that we already have working prototypes of Magnon processors, that's huge.
It really is. This isn't just some science fiction concept anywhere. It's actually happening. Oh, and can we talk about the role of AI in all this for a second? Mind-blowing.
Totally agree. I mean, AI is literally helping us design these insanely complex circuits that we, as humans, can barely wrap our heads around.
And then we got into some of the potential applications of this Magnon technology, and wow, the possibilities are just endless.
From lightning-fast telecommunications to next-level AI to tiny devices that could revolutionize healthcare, and who knows what else. The potential impact is huge.
Huge is an understatement. But like with any emerging technology, there are still some hurdles to overcome.
Yeah, the biggest one right now is figuring out how to shrink these Magnon circuits down to the nanoscale.
Nanoscale. We're talking crazy small. But hey, if scientists and engineers can pull that off.
It would be a game changer.
So what do you think? Do you believe Magnons are the future of computing? Head down to the comments and let us know.
And while you're down there, if you're enjoying this deep dive into the world of Magnons, hit that like button and subscribe to our channel. We're always looking for new topics to explore, so let us know what you're curious about. Your suggestion might just be our next deep dive.
All right, before we wrap things up, we want to leave you with one last thought.
Yeah.
If and maybe when Magnon computers become a reality, what kind of problems will WE be able to solve? What new possibilities will open up? Just imagine the potential. Until next time, keep exploring, keep learning, and keep diving deep.